Petroleum is a fossil fuel, the third of the ones we've studied in this class. It formed the same way a long, long, long time ago. And if you look at the picture in the bottom, it's showing you the same thing that happened with natural gas. Because petroleum and natural gas form together and are generally found together. It's often referred to as, who knows that? Oil. Good. Crude oil. Oil is a major source of energy for the world. Actually, 40% of energy used where comes from petroleum. Well, yeah, for transportation, but used by who? U.S. Us. The Middle East holds the majority of the reserves, and the U.S. holds 2%. The first use of petroleum is, what is this?
The lantern. The kerosene.
Kerosene. How do you spell
Kerosene.
Crude oil is what we refer to as conventional oil, and it looks like a gooey liquid. It's made up of hydrocarbons, and that would be anything that includes excessive amounts of carbon with sulfur, oxygen, and nitrogen. We get it mainly through ocean mining, and that's not the only way, obviously. Once mined, it's transported by pipelines and trucks, haul it and then, or ship it, and it's refined, heated, distilled, and separated by the different boiling points. So you're going to obviously use the petroleum with the highest boiling point for fuel, and you're going to use the petroleum with the least boiling point for industry. All right, so who has it? And I already told you the Middle East has 50%. Here's a more clear interpretation. If we're going to say the three top controllers of petroleum, it's Middle East, then Central and South America, and then Africa, number 3. And then if we divide it more specific, it's Saudi Arabia, holds 25% of the world's reserves. Iran, Iraq, all the names we really don't want to hear. And there they are. World oil reserves. Here is a, by the billion barrels of oil, North America 258, and then you see the whole world has 2,130, and I'm going to give you like a mathematical equation in a little while. The Middle East, you see, has 50% of all the reserves, just by looking at that bar graph. And there's more continuous information about oil reserves, and this says, scary thought, according to the 2005 report by the Institute for the Analysis of Global Security, almost 1/4 of the world's conventional oil is controlled by states that sponsor and condone terrorism. There's 2 ways to look at oil reserves. You've got oil reserves that are proven, or they, then there's other ones that are called unconventional oil, which are believed to exist, okay? And the U.S. actually believes that they have a significant amount to be found. If you notice what we have and what we believe there can be.
How do they like?
Oil reserves, and then we have production, and they're very, very correlated. We produce a lot of oil in the United States because we import the oil and refine it, distill it, heat it, all the things. Our number 1 producer is Texas, and then the other producers are Alaska, California, Louisiana, and Oklahoma. And unfortunately, yes, you have to know all those.
In order.
All right, so who controls it? Government-owned companies control it, and private companies such as Exxon, Chevron, and BP. OPEC stands for Organization of Petroleum Export Countries. Companies. Oh, it's right there. That's so much easier. And it controls most of the world oil and 60% of the world crude oil and produced 43% of the world oil. They just control them. And I added Indonesia because they made it to the list. And they say that there's a lot of little hidden facts about reserves from OPEC. The day comes out. So 85% of energy used comes from the U.S. from fossil fuels. 39 of that is from petroleum, and the main use of petroleum is transportation. And those are pictures of who uses the most, and I'm sure that graph has changed somewhat because I think we're right there with China. So who regulates oil prices? When oil demand exceeds oil production, the prices go up. Oil production peak in the US was in the 70s. Overall, the topic or the buzz of petroleum is that it is relatively cheap when you look at it, and we don't feel that, obviously. But that's what they say. Problems associated with the peaks. Agricultural and industrial products increase. Honestly, I would say everything increases. We felt a big peak probably when diesel hit its peak. Diesel is a product of petroleum. So I'm going to teach you that in a minute. When you refine it, that's one of the products you get. And when that happened, everything went up. I remember if you delivered something to your home, there was a $50 delivery fee because they couldn't afford the transportation. They had to include that as an additional cost. So your mail, that's when the stamps went up. I mean, all these things fall into play. Food production needs to be more localized to avoid increase in prices, but that's not generally going to happen because we rely on food from all over the place. Airfare goes up, auto sales go up and switch to hybrids, and the hybrid prices don't go up. And here's a little graph for you on petroleum refining, and I'm going to go over it in a minute. Right there, gas. I got a big one for you. So, your typical refining of oil. Here's a barrel of crude oil, and 50% of that barrel makes gas. 40% makes diesel, or heating oils, or jet fuels, or kerosene. 10% makes residual fuel oil. And then other products, you've got liquefied petroleum gases, jet fuel, heavy fuel, other distillates, diesel, gasoline. They're there right in between here, okay?
So it's 40% not oil.
Correct. No, all of this is oil. 50% is gas.
So gasoline is the less refined.
Is 50% of a barrel of oil makes gasoline. I'm going to give you better facts right here. Here we go. For 1 barrel of oil, you're going to get 19 gallons of gas. You're going to get 9 gallons of diesel, and the rest is other kinds of fuels like kerosene, coker, which I'll tell you what that is in a minute, aviation fuels, and then you've got non-fuels, which are like used to make asphalt or all these other products, which we'll talk about in a minute. Canada has a lot of this, as I mentioned in the previous slide, or forgot to. This is called oil sand or tar sand, which is a mixture of clay, sand, water, and this thick, heavy oil of sulfur, okay? The advantage is it's kind of now considered to be conventional oil, although there's a lot of disadvantages to this, and I have to cover them. So it increases our reserves. So in other words, they're able to use this product as petroleum, in a sense, as crude oil. Disadvantages, and this is a big debatable topic. These oil sands or tar sands are near forests, so it's going to get to the point where we're going to deplete forests to get to it. Mining is needed for extraction, which at the end of the day, you need to mine for all types of petroleum. Deforestation, as I mentioned, is going to lead to a loss of diversity of many species, because we know the forest holds the majority of species on Earth. Wetlands will have to be drained in order to obtain this. there's going to be extreme degradation of land and more sulfur emissions because it's high sulfur. Now we know coal has high sulfur too, but when you compare petroleum to the oil sand or the tar sand, this is higher in sulfur. So this is oil shales. Oil shales, oily rocks, also composed of hydrocarbons, and they're called kerogen. And they actually have a low net yield, so it's kind of debatable as to why we're even trying. Look at all the disadvantages. They're hard to find. The deposits are located in rock, so it becomes extremely expensive to mine and expensive to refine, to heat. And you need, this is a big topic with oil shales. The amount of water needed for production is extensive. So it's a big downfall, and they find it in areas where water is scarce. So they're actually transporting either what they find or transporting the water to produce it. So it's just, advantages of petroleum in general. They're relatively cheap. They have a high yield. They're easy to transport. Less land disturbance, obviously we're mining in the ocean. Advances in technology. Disadvantages, every type of pollution, and if we do the math at the current consumption rate, there's about 50 years left, and we're gonna need a substitute from OPEC. Ready? 76 million barrels. 76 million barrels are used per day. If we multiply that times 365 days a year, that is about 27,740 per year. If I take that number and I divide it by the total reserves, wow. Was that impactful for you?